All right, hello and welcome to a new day. I want to teach you about some languages other than C++. Today I'm going to teach you Java and Python, and I will not test you on this, but you should still pay attention because depending on what school you end up transferring to, it might be the case that the students there learn Java already. They learned Python already in their intro classes, and I will show you how easy both of those languages are, okay? So it won't be that hard to catch up, I promise. So yeah, I'm just going to show you just a few examples in both Java and Python today. I don't have time for a million things, but I have some good examples, and that will just prove to you that you could learn this language very well on your own if you wanted to put some time into it, okay? There are some fun tutorial websites that I want to link to. So there's a website called learnxandyminutes.com. There's a page on there about Java, and it's just like a really long file, and you can scroll through it and read about what's going on there, what Java's all about. You'll learn the language as you read through it, and there's plenty of other like examples linked at the bottom. So this is a good resource, and this website has a bunch of information about other kinds of languages as well. So take advantage of that if you would like. But surprisingly, you're going to notice that this looks a whole lot like C++. It's going to be great, very similar, and Java is also an object-oriented language like C++, and kind of the idea is that once you learn one, you kind of know them all, which is great. So yeah, let me show you Hello World in Java, and we'll go from there. I just have a bunch of pre-made code today because I have a lot of files to work with. All right, so let's go to helloworld.java. Java likes their camel case, and so it's capital Hello World.java, okay? And it has to be called that with the code that I have inside here, okay? So let's walk through it. This is the file, all right? This is the file. Let me comment out everything that's not Hello World right now. We'll get to that later. Just like that. And don't read the comments yet. All right, so it says public class Hello World, open brace, close brace. So like we make a class. Everything happens inside of a class inside of Java. There's no ending semicolon at the end of the class, which is extra nice. And then the main function is really a method. All right, it's really a method. We say public static void main. Main returns nothing, not an int this time. And then it takes the command line argument. So it's an array of strings called args. And they use capital strings, and for their arrays, they put it the name of the array. It's not like this, but the fact that it's an array next to the type of thing inside that array, which is great. So instead of this, they do this, and honestly, I think that makes more sense to me. And then here is their print function. It's system.out.println. Java. The meme about Java is that it's very wordy. You have to say a lot of words in order to get what you want. So you say that, and then you give the string that you want printed, and it will print it with a new line at the end there. And that's it. It's a void method. And so like it goes out of there. And it's really like a function, though, because it's a static method. So I'll talk about that in a second. But that's the code, more or less. Like public class hello world, public static void main, string args. Those are your command line arguments. And then system.out.println what you want. Okay? So to compile this, we're going to use the Java compiler. Of course, not G++ anymore. Java C, name of the program. Java C, hello world.java, hit enter, and it will compile this into a file called hello world.class. All right, because everything is a class in Java. So that's the compiled form of that of this hello world class. And Python really cares about the naming schemes here. So like you have to, if you're going to make a public class inside of a file called helloworld.java, it has to exactly be called the same name as the file so that you know where everything is in your Java files. Like that is required of you. All right, so like if I messed up even the capitalization, Java C is going to complain. It wouldn't even compile. Isn't that crazy? It's like, all right, this should have been in a file with lowercase helloworld.java. That's what it should have been called. Sorry. I'm not even going to compile it for you. So that gives you some good guarantees about where the thing is, I guess. But this has made this file, helloworld.class, and you cannot do / on it. It doesn't work, okay? That's not how this works in Java. Java compiled programs, yes, they are binary. They're still ones and zeros, but you can't. It's not machine code. It's not capable of being run on my CPU yet. All right, so it's a little bit of a higher level of a file, even though it's still binary. In order to run this, we have to run it inside of what's called the Java virtual machine. So you have to run this program inside of Java itself. All right, so you say Java, the name of the command Java, and then just give the name of the class. It will find the corresponding .class file for you and run the main function there. Okay, so I'll say Java hello world, hit enter, and there it went and ran it. Isn't that beautiful? Nice, nice, nice. And yeah, let's go through these comments now. So let's see here. Yeah, so in every Java file, there has to be a public class. That's like, that corresponds to every file. There's always a public class in it, and that has to be the same name as that file. So hello world.java must hold a public class hello world. And so the access modifiers, they go next to everything. It's like public everywhere. It's not like public colon, it's just public everywhere. And yeah, Java programs, they get main functions, and those always are going to take the command line arguments. You can't have a main function like this. Oops. You can't do it like that. You are forced to always ask for your command line arguments, even if you're not going to use them. And the type of an array, you put those brackets next to the name, next to the type of thing inside of it. So it's a string array called args, and honestly, that makes more sense to me. And then yeah, main, it's acting like a function. Main, for all intents and purposes, is a function because it's marked as static. All right, go back to your CSCI 40 textbook to learn more about what that means. But when you have a static method inside a class, it really kind of belongs to the class itself. So it's really like hello world dot main rather than like you've made a hello world object and there's a main method inside of it. All right, so this is like belonging to the class itself. So that's about as good of a function as you can make. Okay, so it's acting like a function because it's a static method. So go look up static methods if you haven't read about those before. So that's pretty nice. And then yeah, you have to say public, private, all over the place. Those words are still the same, but there's no like public colon or anything. That doesn't exist in Java. You got to mark every individual thing as public. Okay, so there's that. And yeah, system.out has a function, or sorry, a method called println. And system.out really lives inside of a bigger place. It lives inside of not a library in Java. They call them packages. So it lives within the java.lang package, which is by default included for you. And in Java, we say imported, all right, instead of included. And so this full path of system.out is really java.lang.system.out, but this is like default, like included for us. Okay, so that's where that lives. And like you can look at the documentation for that. Like here's a link to that. Look, the Java library is next level, guys. It's amazing. So like here's every class that exists in the Java standard library. So many more than in C++. It's so great. All right, so here's java.lang, that package, and there's plenty more where that came from. Whee! So there's all those packages down in there. We'll look at one other one today. And then if I zoom in, you can see it better. But java.lang has eventually a system class. And the system class contains an out object, just like cout in C++'s IO stream. So the out object is a print stream. What can I do to a print stream? What can I call on it? What methods exist? Scroll down. They have print functions to just print something without a new line. And then they have println functions, or sorry, methods to print, like print a bool, print a char, print a double. Wow, and we're using it on a string. So that's the one we're calling right there. Cool. Prints the strings and then terminates the line. So this documentation page has been generated automatically. It's really, really nice and cool. So there's that. So yeah, look at the documentation. The documentation was automatically generated for the Java language. It's really, really cool. Okay, and then yeah, that's pretty much the program. Here's some other things just to show you that pretty much everything's the same. You make int variables. It's still called int and all that. Like I++, you can print ln I. So let's Java see this and Java run it. So there's the one, and then you can make an array. Everything has to be made on the heap in Java. So you have to say new to make one of those guys. But they do know their length, which is extra nice. So you just say r.length. And remember, it's int bracket bracket r rather than int r bracket bracket. Oops. Like it is in C++. So like that, it's all, the whole type is together, which I think I prefer. All right, but arrays must be made on the heap. You have to make a lot of things on the heap in Java, and yeah, you can go through the whole darn thing just like that. All right, so it's very familiar. I hope that makes sense. All right, so Slightly different yet very similar. All right, so let's spend some time on that. So yeah, there's no pointers to anything. Also, notice how when I said new, I still call it an array. That's fine. There's no need for a star. There's no concept of a pointer in Java. They call them references, sadly. I'll get to that. So yeah, arrays look a little bit different as well. But yeah, in general, Java does not run on our hardware. It compiles into something that is not machine code yet. All right, so Java runs on what's called a virtual machine, and so when you compile Java programs, they can then go and run on any computer with Java installed, which is kind of nice. So let's say, let me fix my pens here. Let's say I write a file called a.java, and you know that there's going to be a public class called a inside of this file. Public class called a, and then you get your curly braces and all that bad stuff. When you say Java C on that file, it will create the .class form of it. It's the compiled form of it, Java C. It creates a .class, which is still binary. It's still close to machine code, ones and zeros. It's still quick to load, but you can't run it on your own machine. This is like at a higher level. It's like an intermediate language, we call it. It's really called Java bytecode. And it is capable of running anywhere that Java is installed, all right? You have to give it to the Java virtual machine, or the JVM for short, which is like a program you must install. It's like a black box, and then it will run only inside of the virtual machine. Which is kind of nice because you can compile it once and then run it anywhere. That's like Java's slogan. It's like this file, you can give it to a Mac, you can give it to Linux, you can give it to Windows, anywhere with Java installed, like it will run. It works everywhere. That's very, very different to compiled C++ programs, because when I compile a C++ program on my terminal, this is a Linux terminal, and it's only capable of running, like I can run it immediately, only on 64-bit Intel Linux, okay? Those are like paired to an operating system and CPU architecture combo, and you can't get around that. But you don't need G++ installed to give this to somebody on that same architecture, if that makes sense. Okay, so that's kind of like the contrast between Java and C++. They chose this way. You have to install Java anywhere, but you only have to compile the thing once. Okay, so there's that. Let's see. So let me do this in a bit of a different order. So arrays, we're making those on the heap. We have to say new to make one, and so here I got back an array, but it's not really a pointer or anything. It's everything you make on the heap in Java, because you're required to use the heap a whole lot more than in C++. Everything you get back is not called a pointer, it's called a reference, which I'm so sorry, that's going to be very confusing when you start using more Java. But Java's kind of taken care of it for you. You don't have to ever dereference anything, first of all, which is nice. It's just like done for you. Here I am, just like R of J, it's fine. And I'll show you more later. And then also notice that I'm not saying delete, not that I forgot to or I'm about to teach it to you, but delete actually does not exist in Java. So like you might think that you're leaking memory all day long, but in reality, Java is calling delete for us. You can't ever do it yourself. There's no such thing as delete in the language. Java is called garbage collected. And so it's just going to notice when I'm done with this array, anything that I made on the heap, Java will notice when I'm done with it, and it will get rid of it for me, which is amazing. I love that. So yeah, that's Java in a nutshell. So I hope that makes a little bit of sense. Please yell at me if you have any questions about this stuff, but that's kind of like the gist of it all. So let me show you a counter class, just like one that counts up, and we'll get to that, okay? So let's go to that file, counter.java. So here it is. Let's see here. Dun, dun, dun. So there's a lot going on here that I want to talk about. All right, so here's a counter class, and I'll try to explain what I'm doing here. Here's the main function. Here I am using counters. It's a static method, right? And so it's not really part of the counter class, really. Like it's still public class counter, but the main method in here, it's a static method, so it's really like a function. And here I am making little mini counters inside of it. Okay, that's fine. Don't be alarmed. All right, so here is how I want to use my library, my counter class. Just make a new one. You have to say new for every object on the heap. It'll be made on the heap, but deleted for me. Here I'm inking it 3 times. That should print 3. make a counter with like a parameterized constructor holding 42. So like this constructor should have made it 0. Ink it to 43. This should have printed 43. And then I want to be able to add two counters together. We'll get to that. So Java C counter dot Java will create, right, counter dot class, and I can Java it to run its main method or main function. So I get my 3, 43, and then this one has to do with adding. I want to add C to C2, and that was like, what, 3 and 43, so we'll just add their counts inside of them. So the count for that one should be 46, which makes sense. Okay, so that's what I want there. And yeah, here's how you implement all these methods. So you say public class counter, and if you set it like this, it's fine. That's what I did for the last one. But by default, every class that you make is inheriting from something. Every class that you make in Java inherits from some base class called object, which is just like a default class that you're always forced to inherit from if you don't inherit from anything else. So like by default, I didn't have to say this, but like I'm making it explicit. There is a type called object in Java that, can I search for it? Yeah, here it is, object. Like what do you get by being an object? It's just like the root of the class hierarchy. Every object has it somewhere. Like you get all these methods for yourself. A way to generate a hash function code, a way to clone the object, and you're probably going to want to like override these things, but like you get all of these methods, like a toString always exists somehow on your object, which is needed by other parts of the library. So like everybody is an object, and you get all those pieces from it, all right? So by default, every class extends object eventually, like somebody like is gonna inherit from object, one way up the hierarchy, okay? So there's that. Let's see. And so now let's make a counter class. So here's all these things, and notice that I'm not declaring anything. There's no such thing as a declaration in Java. You just start writing your code and you're good to go. It's like every counter, what does it need? It needs a count variable, a count member variable, and I guess I'll call that X for fun. Could have called it count. But it'll be a private variable, private int X. You say the access modifier next to everything, okay? So that's check one. You put public / private next to everything. So there's that. Let's see, what else? And so here's my constructor, counter constructor, just like in C++, there is no return type, it's just like return it. It's returning a counter, it makes sense, right? And its count should be set to 0, all right? It's bothering me that this is not called count, so we're gonna change that. Past me didn't do it right. We're gonna call it count everywhere. So everywhere we see it, we're gonna call it count there. So there's that. What else? So here's the constructor. When you make a counter object, it's gonna set the count to 0. There's no like initializer list in Java. You just gotta like do it in the body. And then there's also no such thing as a default parameter. So I could have combined these. This is the parameterized constructor that takes something, starting value, and like sets the count to the 42 or whatever that we pass along. There's no such thing as a default parameter in Java. So we couldn't have like made both of these into one. We couldn't have done something like this, like public counter int starting value like equals 0. That's not a thing, all right? And that exists in C++, all right? I hope you've seen that by now, but like here's a quick example. Like in C++, you can do something like this. You can be like, all right, foo is a function that takes an int called x, and by default, if you don't pass anything, I'll make that x 42, all right? So, and then you give a body. So if you call foo without any arguments, you're allowed to, it will get the default 42 value, and then it will run with that in C++. Though you could also, it still has space for it. You could pass along something else, and that will take precedence, and that will be put into x instead. But if you don't give something, the default is 42. That's a default parameter, all right? So that exists in C++. I guess in Java they thought that was too complicated, so it's like, you got to spell it out in Java and say, like, just give two separate ones, okay? So there's that. And then let me change it to say count everywhere. So count, count, count. Oh gosh. Count. Dun, dun, dun. I think I did it right. Cool. All right. So yeah, it's setting the count to all these things. The getCount method, of course, returns your count member variable. Your inc method increments your count member variable. Reset will reset it back to 0. Or again, you could have made this one with a parameterized, with a default parameter language, but you don't get that in Java. So like reset to 0 without any arguments, or reset to some value that you pass if you do give an argument. All right. So there's that, and so that's all these ones that I'm using down here. And then if I want an add method, sadly in Java, I don't get this. There's no such thing as operator overloading. CC2, no default parameters, no operator overloading. So I don't get this. I can't override the plus operator, which is very unfortunate. Like instead of this, I am forced to say c.add c2. And also, like, I can't do this either. Like, I can't have an equality check. It won't do the right thing. It won't check for, like, counts to be the same. Like, I can't override that either. So I have to make, like, a dot equals method, which sucks. And you have to spell everything out in Java, and that's why people complain. Like, it's very wordy because of this. You have to spell a lot of stuff out. You don't get your operators overloading. So I had to say dot add. So sad. Right? You have to use words. Like, all right, I'm going to make a new counter. It's called add. It takes myself and some other counter. See, how there's no stars or anything, even though everything's made on the heap. It's like they're all called references, and you can just use the dot. It works out. And like, here's the new counter that I want to return. It is a counter based on my current count, and the other's count, and it returns that new counter back, and that I can use and get the count back. So that's why it's 46. Hopefully it's still happy with everything. Yeah. Yay. So there's that. And yeah, there's also no such thing as const. There's no const here. Like my get count should have been marked const, right? That's not a thing in Java. Add as well. It's not messing with my member variable. It's just using it. So it also should have been marked as const. But there's like a way to annotate that things aren't getting modified. And then like also const parameters as well. You don't get those either. There's a way to mark these things, but it's a little complicated, and I don't remember it off the top of my head anyway. So there is a way to do it, but it's not really baked into the language, I would say. So yeah, there's that. That's the counter class. Hopefully you can see how very similar everything is. All right. And did I also say, yeah, there's no declarations, and so just like Java, like you give things even out of order. Like main could have come first. It would have found all the implementation. So you don't have to ever, you never have to declare anything, even if things are out of order in Java. It'll just find the things that you want, which is great. All right. What else do we have for the day? Yeah, let's talk about like, here's just like a big long list of differences between Java and C++. I stole this from Bill Kearney, the other Seaside professor here. Thank you, Bill. So, do I have a file that I want to show this with? I don't think so. Yeah, I think we're good. So, all right. So, yeah. First of all, it's not a compiled language, even though there's a Java C compiler. It's like, it's compiled to an intermediate language, we say. All right. So that's that. That's a thing. It's like this is not ready. This .class file is not ready to run on your architecture. You have to run it through the virtual machine. It's an intermediate language that it's compiling to. All right. So that's the thing. Let's see here. Let's see. Yeah, I think that's what I want to say. So there's that. For const variables, those exist. Those are easy. Instead of const variables, things that can't change, as a variable, you say public static final. All right, so make it part of the class, so it's only there once, and then say final means you can't change it. That's kind of like their const. Okay, so there's that. Instead of char, they say byte. They say byte for stuff. There's that. Yeah, there's no such thing as a pointer. They have references instead. What else? Just like we saw here, there's no operator overloading. It's so sad. I would like that, if only. Yeah, we're going to talk about how to include libraries, and those are called packages, and you import them, right? So there's that, and like that's instead of like namespace and saying $ include, they're called packages, and you import them. Every class, one way or another, will derive from the object-based class. Like everybody is a subclass of object in Java. It's like object gives you a nice information about things, like gives you a hash function, gives you a toString method that usually you're going to want to override, but like you're always guaranteed to have that for every class that you write. One way or another, you're getting like a default one made for you. Everybody's inheriting from the object class. So there's that. The compiler is really nice, honestly. It's a little bit better than C++'s disgusting template errors. And the documentation system, if you hook into it, it automatically generates pretty documentation for you. It's like all of this entire website that I was showing you here, this is generated from the source code for the Java libraries. This is just being extracted out of the source code, and it's generating a website for that, which is amazing. So I love that. What else? Yeah, so you never have to say delete. Everything's getting garbage collected for you by the garbage collector. It's like coming around to your house, picking things out of the trash for you. It notices when you're done with memory, and it reclaims that memory for you. So there's that. And then the libraries are next level. So much better than what you get in C++. It's like night and day. So I'll show you that soon. All right, so let me do one more example before that for a cooler example. Let's do a linked list class. All right, so you can see some more differences. I've got that one right here, linked list.java. So of course, public class linked list, and then let's see here. Here's how I want to use it. Here's the main function. So I'm going to make a linked list. Starts out empty. I'll push back to it, new nodes, and then I'll go through each node. The node lives inside the class, so it's like linked list.node really. I guess technically because I'm inside the class I could have said this, but just to spell it out, I'm going to say it like that. That's going to give me back the first node of the list, and then while it's not equal to null, we say null instead of null pointer, and we say new all the time as well. So there's that. I'm just going to print out the data n equals n arrow. It's not n arrow next, it's n dot next, because every pointer is a reference, and like you can use the dot. There is no arrow operator in Java. So Java C linked list, Java linked list if it doesn't complain. So there's my 1, 2, 3. All right, so this is my list, and let's walk through it now. All right, so every list is made up of nodes. Here's an inner class, right? There's no structs, it's just classes all day long. So here's a class called node, and here's what you get inside of every node object. You get a public int data and a public node next. So there it is, right? Instead of node, sorry, just say node. It's a reference to the next node, all right? So, all right, what does every linked list now need? It needs a member variable holding on to the start of the list. If it's a singly linked list, we're going to say private node first. There it is. It's a reference, right? It's essentially a pointer, but Java calls them references, and you don't use stars. All right, so there's that. And yeah, so when you make your linked list by default, the first node, like there's nothing in the list, so you set first to null. So there's that. And if you want to have a getter for that, you just return whatever's in first. So there's that. Gives back a node. Okay, and then, all right, here's how you push back, right? It's like, here's my new value. If the list is empty, this becomes the one and only node in the list. Like here, first equals a brand new node. Its data and val are these things. The next is always going to be null, right? And then otherwise, if I want to push back to the end of a list, you got to go and search for, if it's not empty, you got to go find the last node. So go iterate through the list. Here I am starting at first, while n.next is not equal to null, advancing. And eventually, once this stops, n.next will be null, and so that marks the last element of the list. So n is the last node, and I'll attach to the end of that. So I'll make my new node with the right value in next. Right, next is always null for the new last node, and the old second to last node, n.next, is going to have as its next pointer my brand new node. And so that's hooking it into the list. All right, so very similar to exactly everything that we've done before, but just like, look at the dots rather than the arrows all over the place. I'm saying new, just like I did in C++ actually, because everything is made on the heap in C++ as well for linked lists. So there's that, and yeah, that's kind of why that's working. So yeah, I just have a bunch of examples today, so do take the time to like pause the video, go look at these files and like draw diagrams yourself. I'd be happy to talk to you about them as well in office hours or something, but I just have too many examples to like stop and draw pictures all day long. Okay, so that's a linked list class. So hopefully you can kind of see the similarities. And now before we get to Python, I have one last cool example. All right, I want to talk about the swing library. All right, so it's called swing, and it's a package, Java x.swing package. It gives me a bunch of objects and methods that create windows. It's amazing. Graphical user interfaces, or GUIs for short, GUI, if you've seen that. It's pronounced GUI, and it's short for graphical user interfaces. And you get a bunch of cool things inside of this swing package. They're going to start with J's, and that's going to give us windows. It's amazing. All right. So let's make a GUI for our counter class. We're going to make like a little window that has buttons on it, so that we can like display, like we're going to hook into our counter. This is going to be a window. It's going to like display our counter's count, like maybe it's 1 right now. It'll have some buttons to like increment the count and decrement the count, and that will allow us to like hook in, right? Hook into the 1, the positive, the negative, right? If you press the 1 button, this will change it to a 2, right? That's what we want right now. If you press the minus button, it'll change it to a 0. Did I have a decrement method? Honestly, don't remember. Let's go back and check. I have ink, right? I guess maybe instead of subtraction and adding like a decrement method, maybe I'll make it reset. I think that's what I'm gonna do. I think that's what I did actually. So let me confirm that real quick. Dun, dun, dun. Yeah, so instead of minus, like you can think that you might want to do it that way, but I'm just gonna say reset. Increment, reset. There. All right, everything's back to normal. And so we're gonna arrange for a window, and it's gonna look great. I've made it already for you. It's in this file here called counterGUI.java. It's gonna use our counter class inside of it. I'll get to that in a second, but let me compile everything. Java. So the counter class, which is being used, is already compiled. So I'm gonna say Java C counterGUI.java. And then I'm going to say Java, that one's going to have the main function I want now. So I'm going to say Java counter GUI. Here's what we're making. Isn't this amazing? It's like here's the increment button, the reset button, and here's like the text window that's showing the current count. 1, 2, 3. When I click it, like I'm finally making windows. This is part of the library for Java. Like this is included. I wish this was true for C++. Isn't that amazing? I love it. So that's what we're making right now, okay? And so to make it, we're going to do some stuff, right? We're going to use the swing library. We're going to say, instead of include, it's import, all right? Or it imports everything from javax.swing, and then also some stuff for like button clicks. Those are part of this event package. So we're going to import that too, okay? So there's that. And then let me kind of walk you through how we're going to build that window, all right? So here's the window I want. These pieces inside of the window, these are called, they have a name. Like this is going to be called a JText field. All right, and these two things are going to be called JButtons. That's just the name that they got in the swing library. These are JButtons. And then to arrange a bunch of these objects, these components they're called. These are the things that are pre-made for you by the library, in the swing library. Then we have to arrange them in a way. Like if you want them arranged horizontally, you put them in what's called a J panel. So this is really meant to be a J panel. And then if you want this to be like a window with a name and all that, like here's my window, it's got this in it, and it's got a name, it's called like counter GUI at the top or something. Like we're calling it counter GUI in the middle or something. Again, GUI stands for graphical user interface. Then you put your J panel, like the thing that corresponds to the entire window itself, that's called a J frame. All right, so these are all in this class, in this package. So here's like the J frame, and here's all the other pieces. So there's a J button right here, J text field. Where is that? Here's the text field that's going to display the current count. And you just click on it and you see what you can do to it. Like, all right, what does the constructor take? How do I build one of these things? You just keep on scrolling. It's like, all right, the J text field like has a bunch of different constructors. It can be initialized to hold some starting text maybe, or initialized to be blank. and then you can do some other stuff, like, and you can set, right? You can set the font inside of it, you can set the text inside of it as well. So let's see. Yeah, that's more or less it. Let's talk about how to use it, all these things. Okay, so everything else gets all this stuff. Yeah, let me say, I want to show you how to set the text really quick. Let me find that method. I think it's just called set text. Did I miss it? Yeah, so here, it's through inheritance that's getting a set text method inside of our text field. And so that's how we're going to change it. We're going to call that. All right, but this is the text field, JText field. And so the outer window is a JFrame. And how does that work? That's the first thing we're going to build. All right, so kind of the setup is, again, we're going to have an underlying counter keeping track of our count. Like, we're going to actually call the inc method and the reset method on it, and we're going to use that to affect like what's displayed. All right. So deep down inside, we are going to have an actual counter to hold our state, and here's that for us. We're just going to call it public static counter. See, it's part of the class. All right. A static variable called C. That's my underlying counter that's holding the information that's inside of this, like, going to be displayed on this window. It's like the database, okay? It's the state, okay? So there's that. What next? And so here's now the main function. So we're going to make a brand new counter to like initialize this, right? Right now it's holding null, nothing, or garbage. And here is me making a brand new counter. It's going to hold on, and that's the one I'm going to call inc and reset on, okay? And then we're going to make the window itself. So here it is. It does have a, if you can zoom in on your video, the title of this window is counter GUI actually, so that's perfect. And here's how you make that new window. That's your JFrame, and the JFrame's constructor takes the name of the window. There it is, counter GUI. You give it just as a string to its constructor. Like that's how this library is dealing with that, right? So I clicked on JFrame. One of its constructors does exactly that. Here is its title. Okay, so there's that. And then for some very odd reason, by default, if you click the X in Java for the JFrames, it doesn't actually close the program, it doesn't actually end the program. And so that's what I want, and so I have to tell it that. Like, the default close operation is exit, please, all right? Just because the original default was not that, all right? So that's what you got to do. And yeah, by default, also, your JFrame is invisible initially, because like you haven't put all the stuff inside of it. You're not going to show it to the user until you put stuff inside of it. And so like initially it's invisible. At the very bottom, that's when I actually make it visible, after I've done everything. Then it's ready. Okay, so that's where we're going to. All right, so there's that. And then let's do everything else. So like, here's the drawing, right? So I want to make a JPanel in which I want to put a JText field and some JButtons. So here's all this. Here's my JPanel, and I'm making the text field that I want to put inside of it. The constructor takes how wide it should be. Like, I want this text field to be able to display 3 characters at once. So it's like extra wide, so it can get up to like 3 digits. I don't want this text field to be editable by the user. See how if I'm typing, it doesn't actually do anything. I promise I just tried to type right now, because we're going to mess with it ourselves in the program, all right? And then the initial text of the text field should be whatever the initial counter's count is, and that's 0, right? So like, take the counter's count, c.getCount. The text needs to be a string, so we're going to convert it to a string. That's integer.toString method. Okay, so there's that. Really, this is like a function on the integer class. It's a static method. Okay, so yeah, initially it's going to hold the 0 string essentially. This is constructing the 0 string, and like that's what our text will be. So like at the start of the program, it's set to that. And then I've also, like, I stole a way to set the font size. Like, I want to make it bigger than usual. So I'm setting the font size of this text field to 32. And I just stole this. This is like a helper method. I stole this from the internet. Apparently that's what you need there. So don't worry too much about that. So there's that. What next? Okay, now I want to make my buttons. So here's JButtonInc, right? And so you give a string, what is the text inside the button, so increment. So there's that, you got to give that, and then also you have to give the code that fires whenever you click that button. All right. So you have to give a click handler, essentially. You have to give a handler for each click. And here I am. I've made a class called Ink Click Handler. All right. I've made it down here. I'll explain it in a second. But you have to have eventually some code that runs whenever you click this button. That's the point of having a button, right? So I'm going to make the handler that hooks in to it's going to mess with, right? This click handler needs to be able to mess with this counter so it can call ink on it. And it also needs to be able to mess with this text field, doesn't it? So I need to give both of those to the click handler. Those will be like hooked in as member variables, okay? So it has access to them, has references to them. And then I have to tell the ink button, like, all right, here is what I want you to do. Like, use this object. Whenever you get clicked, run the action inside of it, all right? It's called an action listener. Action listener, that's their word for handler, all right? You're installing it, and then also make the button have a big font size. So yeah, here's how you hook into that and have code that runs. You make in a subclass of the action listener class, all right? So this is a little complicated, but it's not really a subclass, all right? I said that to mean something that you know, but really this is called an interface, all right? We're going to say implements rather than extends action listener. We say implements action listener. Implements is for something called an interface, which is essentially an abstract class. You can think of it like we are subclassing an abstract class. It's a little bit different, but that's, I think, as much as you want to say, all right? So to implement all the virtual things, right? All the things that you're required to for the interface, you have to have just one method, an action performed method. That's the code that's going to get called whenever this event fires, essentially. All right. So all right, for this particular click handler, I need the counter. I need to mess with the counter and the text field. So I'm getting those both in my constructor. So here I am setting them, calling them C and TF. And then when the button gets clicked, it's going to call this particular method. It has to be called action performed. That's part of this interface, okay? So it's getting the click event if we needed it, but honestly, we just need to know that we're getting called. So like, here's what I want to do whenever I get called. Whenever the button gets pressed, it's going to run this exact code, c.ink, make the counter bigger, and then also display the new count on the text field. So tf.setText to be the new counter's count as a string, of course, all right? So it's a little complicated, but like that's how the class works, all right? That's what happens. And so you can look at the documentation for that, like add action listener, like every J button gets that, like you can click around and find that. But that's essentially what's happening, all right? That's the ink button. Then the reset button is similar, like make a J button called reset. You can do the same thing for an action listener, but there's a way to kind of like lambdas in C++. There's a much easier way to handle clicks. You can make an anonymous class, just like you could make an anonymous function in C++. Here I am making an anonymous action listener kind of object, all right? And so like I'm adding it as well as like here I am implementing the code as well. Like a new action listener, and here's the one thing, that action performed thing that I need. I'm just giving the code in line, all right? What do I want to do? What's the code that I want to run whenever the reset button gets pressed? I want to call reset on the underlying counter C, and then display the new count on the counter screen, on the text field called TF. Those two things. And so I just give those two lines. It's much quicker and easier, and that's that one. And I can set the font size, and then I've got these things. I've got all these things ready. These objects are ready. I've got the text field, the J buttons. I need to add them into the panel in order. So text field first, then the ink button, then the reset button. They're going to be displayed horizontally. And then I've got all those things. I'm going to add the panel to the frame. Got to do that too. So add the panel to the frame, and then you say frame.pack. And what that does is by default, for a weird reason, like by default, the size of the window in, I don't think I can show it to you, but like yeah, in Java land, the size of the window is like that by default. Either that or like some default weird value. You just have to tell it, hey, you know, I've put everything I want to put into the window, Java. Resize it to just perfectly fit everything. That's what .pack does, all right? And then we're going to say, all right, the frame was invisible. Now it's ready. It's ready to be shown. Set it to be visible. We're good to go, all right? So that's the secret. That's how you make this, and that's why it works, all right? So I'd be happy to explain this more in office hours. Please yell at me. But that's, I think, all that we have time for today. But it's a really cool example, and you can see how powerful just the default libraries in Java are as well. So yeah, that's your crash course in Java for the day. Let's next talk about Python when we have a little bit more time. All right, so there's a nice documentation page for that as well on the same website, Learn X in Y Minutes. So here's Python, just like scroll through it, learn some Python, and there's some cool links at the end to learn more. But yeah, Python is a little bit simpler, I would say. Most schools aren't teaching Java first these days. They're, if anything, they're going to probably teach Python first. And so it's very popular and you need to know it. So let's do Hello World in Python. So this, you're going to see very quickly why this is like a lot of schools' first language, okay? It's going to be one line of code for Hello World. It's amazing, okay? So here is the Hello World file for Python. Just like it's not .cpp for Java files, it's .java, it's .py for Python programs. Boop. So, let me comment out everything else. Here's your Hello World program. Just, you don't have anything else. Print Hello World. It's a print function. You call it, and you're done. All right. It's one line of code. It's amazing. It just runs. All right. So, it's really cool. The single line comments in Java, they start with a number sign like makefiles. So there's not 2 slashes. It's just a number sign. All right. And you just say print. There's no semicolons either. None of that. So it's one line of code. There's no such thing as a main function. You don't really need one in Python. There's a way to get at a similar thing, but like by default, it'll just run all the lines in your file. So you don't need like anything extra, just like that one line. That's your hello world. Just start writing your code, all right? And then to run this file, you give it to Python, all right? It's not compiled. You just say Python, Python 3 really. It's the version of Python. And then you give it the name of the file, hello.py, and it runs it. There's hello world for you. Isn't that nice? So I love it. Let's see. Do I want to do this? Yeah. So let's go down to here. So differences between Python and C++. The first thing is there is no like Python C, even like there is Java C. Python is just like going straight to this file and running all the things. Python is called an interpreted language. All right. It is not compiled at all. There's no compilation process by default in Python. And so it's really just reading character by character in this file, trying to figure out, oh, okay, you wanted to print. What are we printing? Let's read all these characters. Like it's reading the exact file every time you want to run this program. And that's really, really slow. It's not going to machine code at all. All right, so it's much slower, like 10 times slower compared to C++ and Java. All right. So think carefully. If you have something that takes time, you probably don't want to use Python for it. Though there are ways to run Python in a way that's compiled like Java. There's something called, it's called like PyPy, if you want to look into that. That has what's called a compiler. It's called a just-in-time compiler. It's very similar to running on a Java virtual machine at that point. So there are ways to make Python faster, but by default, it's an interpreted language. There is no compilation. Okay, so it's a little bit slower than usual. There's that. And then the rest... Let me just show you this first. The multi-line comments, there's just like a big long string with three ticks. Either 3 quotes, double quotes, or single quotes. So here, first thing, there's no, Python does not care. There's no such thing as a single character. So it's always a string. So you're using either double quotes or single quotes for strings in Python. There's no difference. Multi-line comments are just like big long triple quoted strings. This could have been single quotes. All right. There's that. Python also, if you just run it by itself, it has what's called a REPL. You just say Python 3. I use this a lot. It's like for quick math. It plops you into what's called a REPL, which is called a read, evaluate, print loop. All right, that's what it's short for. So it'll read your code, 2 + 2. You hit enter, it evaluates it, and then it prints out the answer and loops again, so you can do more things. Like you can put individual lines of Python code, give it to the REPL, and it will run those things. And then it's like Control D to exit. Or you can say like quit function call. That works too. So, okay. Let's get started. Here's how you make a variable in Python. X equals 42. And X could have any type. You don't declare types in Python. So it's called dynamic typing. There's no types or even return types for functions. Okay? That's a little weird. I think you can see. So there's that. Yeah, so this will print 42. You can just as easily change what x holds and make it a string instead. That should make you feel very uneasy. That's fine in Python though. Let me comment out the rest of this, show you that. So this will print 42 in HIMON, and x is happy. It does not care that it holds different types. It knows its types if you asked for it. Python knows the types of things, but it just doesn't care. All right. To make a function, there's no such thing as a return type, so you gotta say something different. It's called def to define a function. And you can return any type. You can return different types depending on the way that you've traversed through the function even. It's crazy. So there's no return types. You just say def for a function, like it takes a parameter called x. Who knows what its type is? Could be anything. And then apparently this one's just gonna print x plus 1. And so this should print 43 when I call it. There it is. What else? And then notice how there's no curly braces as well. To make a function, you say colon, then you indent. You give what in the world should be the body. It's an indented thing. So you're forced to stick to your same indentation until you're done with your body there, which is really nice. All right. So let's see. How do I want to do this? Yeah, so white space really matters in Python. You have to tab over, essentially. There's no braces, there's just white space, and so that makes your functions, like, it makes them look very clean, because you have no semicolons. You're just, like, forced to have everything on one line, indented and clean, which is very nice. Good for first-time programmers. So there's that. Instead of arrays, Python uses things called lists. So here's a list L that holds 1, then 2, then 3 in that order. And you can put different types in it. This could have been high, which is disgusting, but you could have done that in Python. So there's that. So there's my list, and you can go through it with a for loop for every x and L. That'll get the 1, the 2, and the 3 out, and you can do stuff with it. So there's my 42, 84, 126, apparently. That's 1, 2, and 3 times 42. So yeah, that's lists. Those are your things. If else are pretty similar. Instead of else if though, you're saying elif. That's a thing. That should be here somewhere. Elif. So here's like an example if statement. There's no braces around the conditions either. But it's like elif instead of else if. They chose that for some reason, and everything's nice and indented. Isn't that beautiful? So there's that. Let's see. Methods, which I'll show you in a second. They have to declare that secret this parameter that every method gets in C++ and Java. That's actually going to be declared. That's like your secret 0th parameter, and we're calling it self in Python. You have to give that when you implement it, but not when you call it. And I'll explain what I mean in just a second. All right, so there's that. So remember that in C++, when you say, like, you call the foo method on some object, what happens in C++ at least, it's going to pass the object itself as the secret 0th argument. It's really like, it's going to make a function call. Every method is secretly a function that takes the address of the object by default. If there wasn't any argument, it's really getting an argument that is the address of the object itself. And that's being shoved into the this keyword variable. Okay? Python has something similar. It's more explicit, and it's called self. All right, we'll get to that. And the libraries are also next level in Python. All right, so I'll show you one of those in a second. Let's do a counter class just to show a lot of that. Notice that there's going to be a lot of indentation, but let's do a counter example. Counter.py. So it's called class counter. Let me show you how I'm using it. So of course I'm giving a colon and indenting. Here's everything inside the class first of all, and then here's me using it. All right, so there's no new in Python. It's just like say c equals, call the constructor, c equals new counter. Just call that constructor by itself, and then you say c.inc, c.inc, c.inc. As usual, there's no semicolons. c.get. Let's call it count again, because I don't know why I called it x before, but we're calling it count this time. I'm fixing it. So here I am changing it to count. Give me a second to mess with that. Calling it count. Whee! There. It's happy. Calling it get count. Python 3, counter.py, and so this is just a fancy program that prints 3. Okay? But now let's look at the class itself. How is this implemented? Well, First of all, there's no declaration of member variables. You're defining member variables inside the constructor, okay? And the constructor, it's not called the same name as the class for once. It's called underscore underscore init underscore underscore. I know that's very odd. So that's what the constructor is called instead of the name of the class. That's just what they chose in Python. And by default, you're explicitly talking about your this pointer, essentially. It's called self, and it's like a reference to yourself in Python. By default, that's what's happening. So instead of you saying c.inc, this is really being translated into, right? This turns into a call to inc with c passed along as the self thing, all right? And that's kind of how you're explicitly implementing it here. You're passing along, you're talking about the self thing explicitly, even though when you call it, it's implicit, all right? So there's that. So init takes your self, and here's how you give it a member variable, self.count. Here's a member variable inside myself, started at 0. This is going to create and define that member variable and initialize it. So there's that. You want to inc yourself. That's going to be also there's no operator overloading. There is operator overloading in Python. Excuse me. So I could have like overloaded a kind of like some sort of operator for this, like a plus operator maybe, but there is no plus operator specifically in Python, sadly. So if I want to increment the count, I can't say self.count plus. I am giving self though explicitly here. I don't say plus, it's got to be like the shortest you can do it is plus equals. That still exists in Python. There is no plus though. Another weird quirk of the language. There's that. You do have operator overloading though, all right? So look into that if you're interested. And then to get your count back, it's like, all right, you're explicitly talking about yourself, even though it's an implicit thing when you call it. It's explicit when you're creating and implementing the class. You return your self.count. All right, so that's kind of how you access your member variable. You got to go through yourself. There's no other way around it. So you're kind of forced to use this anyway. All right, so there's that. It's kind of the equivalent of going through this inside of C++. So yeah, that is why this prints 3. So that's that. So I hope that was interesting and cool. The last thing I want to show you is there's a library called the Turtle library. It's very cute. I use this in my CSCI 1 class. I teach Python in my CSCI 1 class for a while. And so there's a library called Turtle in Python. And here's the documentation for it. It's really cute. It lets you draw things. All right. So the metaphor is that there is a sentient turtle. I guess all turtles are sentient. Excuse me. There is a turtle that understands English. Here's my artist rendition of a turtle. And here's his tail. And somehow the turtle's tail got dipped in ink. All right. So somehow, not naming names, but somehow the turtle's tail got dipped in ink, and the turtle understands English, and you can tell him to move. Like go forward 100 units, turn left 90 degrees, go forward 50 units, turn left 90 degrees, go forward 25 units. You can tell him to do that kind of stuff, and he will draw with his tail down on the page, essentially, which is really cute. I love it. It's a fun way to teach programming. So I'm sorry you didn't have this until now, but I'm going to show it to you before we go. All right, so we're going to say import turtle just like in Python, or just like in Java in Python, to include a library. It's called importing it. So we're going to import the turtle library, and then we get access to all these fancy functions inside of it. All these bad boys. Tell the turtle to go forward, tell him to go backward, tell him to turn left by 90 degrees. And so that's kind of how that works. All right, so let me show you that code. Turtle stuff.py. So here's a silly example of like drawing a box, I think. So yeah, here's turtle, import turtle we say. And then when you include a library by default in Python, the functions inside that library, you have to use the dot to get them. So it's like namespaced in a way. So it's like I want the shape function inside the turtle library, just in case there was a shape function inside of some other library that you've imported. Like you have a way of getting it both. So it's turtle.shape, turtle.forward, turtle.left, turtle.right. And so this one turns the turtle into a turtle. You pass along the string shape you want him to be. Could have been a circle, a triangle. We're gonna make him a turtle. And then here I am. By default, the turtle is facing right or east. And so I say go forward 100 units. I'll draw that. Then I say turn left 90 degrees, so it was facing that direction. I want him to turn left 90 degrees, like that. And now he'll face this direction. I want him to go forward another 100 units, and then do the same thing. All right, a few more times to draw stuff. All right, so let's see. I guess I'm not drawing exactly that. I'm going forward 50. I'm not drawing a perfect square, am I? Forward 50, turn left, and then go forward 75. So I'm doing something like that, I guess. There, turtle that done. Turtle that done, just like, now I'm done, keep the window open. Python 3 turtle stuff.py. Oh shoot, I don't have this installed here, do I? Dun dun dun. Well, let's see what's the best way to do this. Give me a second, I have to pause the video. Python 3, is that a thing? I think, oh, Python 3-TK? Let me try that. If that doesn't work, I'll pause the video and fix it myself. I've never tried to run it this way before, that's why. Let's try it now. Oh yeah, look at that. Okay, cool. So there it is. There's my program, and you saw the turtle move too. Isn't that really cool? So let me redo it. So you'll see him go forward 100, left 90, forward 50, left 90 again, forward 75. So he drew that. His tail is down by default, and he's a cute little turtle. I love that. So there's that. That's the turtle library. And yeah, you can do some really cool stuff. And so I've given you some sample programs that I don't have any time to explain. Here's a sample program that draws the Mandelbrot fractal, if you've heard of that. So here I am doing turtle stuff, making functions, using complex numbers, because that's how you generate the Mandelbrot fractal. So here's like an if statement, and here's like a big long for loop. So look into this. I'll have it run. I'll explain it. I'm not going to have any time to explain this, but oh gosh, what has happened here? It's working very hard, obviously. There it goes. It took some time. So I was drawing this fractal with the turtle. It's very cute. You have the little turtle at the end there. So I do not have time to explain what's going on, but it's kind of like iterating through coordinates and figuring out, is that coordinate on the fractal? If so, I will draw a pixel right there by making the turtle go forward 1 unit, drawing 1 pixel, and that's essentially it. All right, so here's my Mandelbrot fractal, and you also get an extra turtle at the end of that. So like, look into these examples. They're more complicated examples to kind of see what Python can do for you. I also have one that draws that that joy division thing. So have you seen this before? All the hipsters wearing the Joy Division shirt. It really comes from the oscillation of a pulsar. Let me show this to you. That album cover from the band Joy Division. Again, it's gonna take its sweet time and eventually display itself to us. This, I'll show it to you, I guess, in a second. But you'll know it. Most of you will know this picture once it draws it. But the picture that was on that album cover comes from comes from the data from a celestial object, like the pulse of a pulsar, which is really cool. It's from this album cover. So I'm trying to draw this picture right here. It's very small on Wikipedia, but like this picture, you've seen it probably. Hipsters wearing that shirt with that on it. So we're gonna draw that in Python, and so it comes from like the data from this pulsar, and we can just get that data. Like here's the signal. Like the signal was weak, it got weaker, got even weaker, and then it got a little bit stronger. Like here are the pulses of the pulsar, and we're just gonna draw that. Is it really not gonna let me see it yet? There it goes. It finished. So yeah, I had the Python program do that 1 line at a time. All right, let's see if I can rerun it and like resize it so you can see that. There are some bugs in this Windows version of this. But if I try this enough, I think eventually it shows it to us. And I kind of want to show it to you as it's drawing. There it goes. So see how it's drawing it right there? So it's drawing it 1 line at a time. It's kind of overwriting. Okay, that's how that works. And so it's just drawing this. Like, all right, start down, go down further, go down. It's like the offsets go up a little bit, go up some more, because it got less negative, got more negative, so go down. It's like it's drawing the peaks and valleys of this pulsar's data. So I'm just going to iterate through the signal. It's a list of lists, and use it to draw cool stuff. So I've got to draw a rectangle function, draw a polygon function, draw a line function. It's like drawing the fuzzy line that's going up and down. And then here I am just kind of like iterating through every piece of the signal and drawing that fuzzy line at a certain like coordinate, like you're moving downwards. Like that's how this got made, right? It's kind of overlapping itself. So like you've got to overwrite the previous things that you've drawn. And so it was fun to figure out this program, but I have no time at all to explain it. Sorry. You'll have to look at it and ask me about it in office hours. But it's a useful example to show you kind of like the power of just even this turtle library, which is meant to be simpler. Like you can do really cool things with it. You can draw the Joy Division album cover, and you also get an extra cute turtle at the bottom right, just by default, which is very nice, an extra nice touch, right? So I think that is all that I wanted to say about Python today. I gave you some cool examples at the end, just like I gave you a cool example of Java, graphical user interfaces. And so these are two languages that are not too far away from C++, right? They're familiar, yet slightly different. They're not too hard to learn, I promise. You will probably have to learn at least one of them by the time you transfer, so it's a good time to like get good at it now, right? Get good at it now so that you don't have to waste time when you get to your college of choice when you transfer. Okay, so yeah, I think that's what I wanted to say, and I will not test you on any of this. That's the last thing I think I want to talk about. This is just for your knowledge, just for you when you get to a four-year college. So thank you for your attention, and I will see you next time.